Okay, I got a demonstration here that I want to do. I've made a discovery when it comes to the values of what we measure for electromagnetic wave mechanics, and the idea that, well, that everything is only limited by what we call the Planck scale. It is widely accepted in mainstream physics that the Planck scale, or the Planck's constant more specifically, the 6.6260715, is the lowest number that you can go to in quantum mechanics. That anything calculated past this number at the negative 34th decimal place, that's 34 zeros in front of the 6, a number that has 34 zeros in front of it, is the lowest point that you can accurately measure in quantum mechanics Planckian scales. Now, this is going to be a very simple demonstration on how that is not true. I've made a calculating tool that takes a wavelength and it gives you its frequency, its energy, its momentum, its mass, its force, its wave period, and it does all this with just the input of wavelength. And for this example, I'm going to be using a wavelength of 1 meter. All right, here we go. Okay, here we go. So now we're finally going to go to 1 meter here. Sorry about that. So I had PowerShell pulled up here. So there we go. So this is the calculations for 1 meter, wavelength of 1 meter. So it gives us a frequency of the speed of light. It gives us a momentum of Planck's constant, h, right here. This is Planck's constant to the negative 34 power. But it also gives us a couple of other numbers as well. It gives us this number right here for mass. It gives us this number right here for force. And it gives us this number right here for wave period. Now notice that we're still within Planck scale regimes. The force is a little bit past the Planck scale, but this still is within means of quantum mechanics. It's right at the boundary line though. But now this is what I'm going to take this wave period right here, this number, and I'm going to use this number as my next wavelength input. Now, I know what people are going to say to this. They're going to say, oh, you can't do that. That's mixing dimensional units. You can't mix dimensional units. That breaks the physics. Well, I'm going to prove to you that that does not work. That is not accurate when it comes to wave period and wavelength. wave period and wavelength are dimensionally connected, because if you take this wavelength right here that I just did and this wave period right here that I just calculated, you'll find that the difference between this number and this number is exactly the speed of light. So the speed of light is the dimensional connection between wavelength and wave period. So by taking wave period and using it as a wavelength, you're essentially doing a leapfrog step in dimensional scales. You're scaling everything by the speed of light, and everything in between gets scaled by c squared. Now what happens when everything gets scaled by c squared? Well, look what happens to the frequency. The frequency went from the speed of light to the speed of light squared. And when you multiply the rest of the units by the speed of light, look what happens. Planck's constant has now been shifted from momentum to mass. And look, the one that was at mass before is now at force. So these two numbers shifted one row each, and so did these other numbers. So here's the 159 number. Wait, maybe those aren't the same. Oh, I thought these were the same. Oh no, this one is right here. The 19644 number is right here for energy. So energy shifts as well. So energy, momentum, mass, all shift one row when you take wavelength or wave period and use it as a wavelength, and everything gets multiplied by the speed of light, and all of these values shift one dimensional row to the other. This is why the Planck scale right here is considered the lowest possible measurement in quantum mechanics, because during this shifting, this dimensional shift, the Planck number, h, jumps between momentum to mass to force. Watch, if I take the wave period now for this one, and I use that as my wavelength input now, look what happens. Frequency gets multiplied by the speed of light again. So this is the speed of light squared multiplied by the speed of light again. And if you look here, this number right here has shifted to mass. Planck's constant h has shifted to force. And as far as where the other numbers go, maybe they go into a different dimensional state for all I know. I don't know exactly where the other numbers go, but this number shifts, and so does the other numbers. But the thing is, the other numbers disappeared. We don't see them anymore. So we'll go back and we'll take this one before it disappears, and we'll use this one as a wavelength. See, I know people are going to be really, really skeptical about this, because I'm taking numbers that are normally not mixed dimensionally. You know, energy and mass are usually interchangeable because of E equals mc squared, but usually something in meters is not interchangeable with something like a force. You know, you can't take a force and use it as a measurement in meters. You usually can't do that. But this is mathematically showing that these values, only these values right here, are actually shifting between these dimensional values. So these ones, like Planck's constant, can be used as an interdimensional value. Same with this number, same with this number, and the same with this number. all these numbers here are interdimensionally changeable with these. You can change them to these different values. And you can use them as wavelengths. And I'll prove that by doing the actual math. My tool does the math for me, so I don't have to do it all longhand. So all I have to do is input the wavelength like this, and look what happens. Look at these values. Look at energy. Energy is the speed of light squared exactly. Momentum is the speed of light exactly. Mass is 1 kilogram exactly. All from this interdimensional changeable number. This is a constant that is dimensionally changeable. You can use this as wavelength. You can use this as mass. You can use this as force. This number works for all of these different values. So does Planck's constant. So does this number right here. See how this number shifted? This number was right here before. Where'd it go? I just saw it. There it is. See, it was right here under force. So when you start off with 1 meter, each one of these values right here is a locked-in measurement. And they all happened in the early past when frequency reached a value of c squared, of a division of c squared. And when frequency gets to a value of c squared, then the dimensional shift happens. Planck's constant moves. This number, the 22102 number constant, moves. And you can shift it again by taking the wave period and calculating it as wavelength, and then everything gets multiplied by the speed of light and everything shifts one-dimensional state. But by going back to these original numbers, like this one, for example, this one is past the Planck scale. This is at negative 51 decimal places, which is actually past the Planck scale now. And I can mathematically prove that you can go beyond the Planck scale just like this, and I call these sub-C scales. These are sub-C measurement scales. These are not Planck scales. These are past the Planck scales. These are sub-C, beyond Planck scale regimes. See, look, I just did this one as a wavelength, this number, which is a 1 meter constant, 1 meter wavelength constant, and look what it gave me. It gave me momentum as the speed of light squared. It gave me energy as the speed of light squared times the speed of light again. It gave me mass as exactly the speed of light, and it gave me force as exactly 1. And look, here's that 19515 number, it looks like. These numbers, they keep showing up. Well, this is 152. This is 15915. Yeah, 19515. Yep, so this number right here is the same as this number up here at 1 meter. See, look, 15915. This is radius right here. Radius of 1 meter at the speed of light. And down here, it's been shifted to temperature. So somehow, radius turns into temperature. And look at the difference between radius and temperature. Radius is at a negative 51 decimal place, and temperature is at a precise decimal value that is far larger. Like, this is a huge number compared to what it was up here. Up here, it's at 0 point this meters. This is below 1. This is 0.1 of a meter. Versus down here, it's not even in meters anymore. It's in Kelvin, but it's now a number that is this. So somehow, radius gets dimensionally shifted into temperature by doing these dimensional shifts. Now, I'm not quite sure exactly what the physics is behind this, because I can't explain the physics behind it yet. I'm just showing what the math is showing me. That's all I'm doing here. I'm not making any wild claims. I'm not saying anybody is wrong. I'm not saying anybody is anything like that. All I'm showing is what the math is showing me when I move wavelength and wave period around, and I get these same numbers, my results, over and over. That means that there is a consistency in the structure that I am revealing here. That you can go to sub-C beyond Planck scales, and these relationships between these numbers and these constants still holds. So it is possible to measure past H, past the Planck scale, to negative 59 decimal places and beyond. The mathematics shows this very clearly. So it's not wrong that people think that they can't calculate past the Planck scale. It's just that nobody has been able to, so they think it's not possible. But I have just shown right here that it is possible if you do it correctly. Okay? I'm not stating that anybody's wrong. I'm not stating that I'm making any wild claims about physics or dimensional shifts or traveling. All I'm saying is this is what the numbers are showing me. This is what the math does. And there's no arguing that, because this is absolutely reproducible. Anybody can do this themselves. All you do is you just take these numbers and you do the math, and you get these as the results. If you don't believe me, do the math yourself, and you'll see exactly what I saw. You'll see all these numbers shift one-dimensional row. Everything gets multiplied by the speed of light every time that happens. And that's what the math shows me at sub-C beyond Planckian scales. And that's what this video is about. Thank you for watching, and hopefully you learned something.